Generate a heat map using a scatter data set. I have a set of x, y data points, about 10k, that are easy to plot as a scatter plot but that I would like to represent as a heat map. I looked through the examples in matplotlib and they all seem to already start with heat map cell values to generate the image. Is there a method that converts a bunch of x, y, all different, to a heat map, where zones with higher frequency of x, y would be warmer?
In matplotlib lexicon, I think you want a hexbin plot. If you're not familiar with this type of plot, it's just a bivariate histogram in which the xy plane is tessellated by a regular grid of hexagons. So from a histogram, you can just count the number of points falling in each hexagon, discretize the plotting region as a set of windows, assign each point to one of these windows. Finally, map the windows onto a color array, and you've got a hexbin diagram. Though less commonly used than e.g., circles or squares, that hexagons are a better choice for the geometry of the binning container is intuitive. Hexagons have nearest neighbor symmetry, e.g., square bins don't, e.g., the distance from a point on a square's border to a point inside that square is not everywhere equal, and hexagon is the highest in polygon that gives regular plane tessellation, i.e., you can safely remodel your kitchen floor with hexagonal-shaped tiles because you won't have any void space between the tiles when you are finished. Not true for all other higher n is greater than or equal to 7 polygons. Matplotlib uses the term hexbin plot. So do, as far as I know, all of the plotting libraries for R. Still, I don't know if this is the generally accepted term for plots of this type, though I suspect it's likely given that hexbin is short for hexagonal binning, which describes the essential step in preparing the data for display.
If you don't want hexagons, you can use number pwise histogram 2D function.
If you are using 1.2.x, instead of using np.hist2d, which in general produces quite ugly histograms, I would like to recycle pwise viewer, a Python package for rendering particle simulations using an adaptive smoothing kernel, and that can be easily installed from pip, see webpage documentation. Consider the following code, which is based on the example. Which produces the following image. As you see, the images look pretty nice, and we are able to identify different substructures on it. These images are constructed spreading a given weight for every point within a certain domain, defined by the smoothing length, which in turns is given by the distance to the closer NB neighbor. I've chosen 16, 32, and 64 for the examples. So, higher density regions typically are spread over smaller regions compared to lower density regions. The function myplot is just a very simple function that I've written in order to give the x, y data to pwise viewer to do the magic.